I want to talk about the foundation for secular morality and actually present a foundation for secular morality that to me feels the best one, the correct one, um, and see whether you have the same feeling. I expect that if you have worked with this topic and you've seen other definitions, other foundations, then I think they should instantly feel as the right thing. Just to give you a small preview, it will turn out that the foundation for secular morality is a mathematical algorithm discoverable by the process of the natural selection. I think that should instantly feel like, oh yeah, that's exactly what I would expect the foundation for secular morality to be. That seems like the right thing. So if you understand, if you know the topic, you're welcome to go straight to the second part of the video. I will try to put the link on the screen to take you right there. But if you're new to the topic, let me spend a few minutes trying to explain what I mean by the foundation for secular morality. Um, well, we'll know what morality is. We are all born with a sense of right and wrong. If I close my eyes and look in my heart, it will tell me that theft is a bad thing. Thou should not steal. That I will kind of hear that my heart say that. It seems to be inscribed on my heart. Yeah. Um, so why? But I mean, that's perfectly fine. I can live my life with that. I don't need to look for a foundation or reason why I feel like that. I could be pretty happy about it. But what if I encounter another person whose heart tells him exactly the opposite? His heart says stealing is a wonderful thing, it's a virtue. So if I find myself debating this person, um, then how do I go about showing his person that my feelings are correct and his feelings are wrong? Obviously, I will try to appeal to some sort of authority beyond my feelings and try to say, well, we both seem to agree that that authority is a reliable authority, and then I'll try to build my case on top of that authority, so to speak, and justify that my feelings somehow comply with that authority better than his feelings. That's the reason why we want to find foundation for morality. Now, you can try to do this in two ways. Foundation for morality, you can found it in religion, or you can do it without religion. So if you try to do it without religion, then that's what we will be doing today, trying to um, build morality and create foundation for it without religion. Now, with religion, it's very easy, or at least it feels very easy. In reality, obviously, if you try to question it, you will find a lot of interesting questions, problems with it. But it feels very straightforward. I mean, you presume God, and God just randomly comes up with a list. These things are evil, and the other ones are good. And then God creates the universe um, creates universe so that that list is actually somehow built in, just like gravity is built in, or gravitational constant is built in. So he's built the universe in a way that those things about good and evil just somehow apply, just permeate the universe. And when you are born into the universe, whether you're a believer or not, you're automatically a beneficiary of this. In another version, when you're born, God inscribes it on your heart. That basically, metaphorically probably, that list is kind of inscribed on your heart by God. So this is perfectly satisfactory for believers, I guess, and for them that explains why a religious person can be a moral person, and also why even non-believers could be sometimes virtuous and good people. But obviously that explanation is will not work for a non-believer. Non-believers want to also be able to appeal to some sort of authority, not God, other than God, and try to ground their morality on that non-personal authority, so to speak. And that's what we will try to do right now. So this is exactly what we're going to do now. We are going to come up with a way to build a foundation for morality without appealing to God. And I'm going to try to do it with an analogy, somewhat elaborate analogy, somewhat complicated, convoluted, nothing complicated, just slightly long. It may feel a bit artificial, but I think as we go along, you'll see it will start to make sense that it's not actually artificial. So imagine that you are a software developer and you have just been interviewed and hired for a new position. So this company that makes robots, they hired 10 new software developers and you're one of them. And on the first day, they take you to the company, all 10 of you, and they take you to this enormous room and you see 1,000 brand new robots, and they're not yet turned on. They're not yet fully ready. They miss this little piece of software that 10 of you are responsible for writing. And the company explains to you that in about a year, these robots should be ready after you finish this little piece of software. And these robots will be turned on and they will start doing the same things that living organisms do. So they will start interacting with each other, maybe fighting, maybe cooperating, sharing some resources, discovering these resources which are spread along the room. There are some batteries, there are some other resources in the room that they will be sharing. Also, they will be producing offspring, so they will be mating somehow and producing offsprings, which will be kind of similar to the parents, etc., etc. And the ones that, for example, cannot find the mate will not obviously have offsprings. Those that run out of power, run out of resources, run out of food, they will probably die, or maybe they can fight and destroy each other, etc., etc. So it's very similar to a normal situation where living organisms find themselves. So when these 1,000 robots are turned on, they will start mimicking the process of life, basically. But they miss this. They're missing this little piece of software that 10 of you are responsible to write. And the company calls this little piece of software that is missing, they call it, how should they call it? Gene for Morality. It's a weird name. You don't really care about it. It doesn't really make sense to you at this point, but you don't, I mean, it doesn't matter to you because you're a good software developer. And obviously, you wonder what it is that your software should do, and this is what they tell you. This is what the company tells you. So you are responsible for this 100 robots. So there are thousands of robots, but they apportion to you 100 of them. And another guy that they've hired, he will take another 100, and then next person they've hired, she will take another 100. So 10 of you will be allocated 100 robots each. And the piece of software that you will write will go into this 100 robots that have been allocated to you. And when the robots are turned on, your piece of software will simultaneously wake up in all of the 100 robots that are allocated to you. And it will govern important aspects of the robot's interaction between each other. So, for example, when two robots see a single resource, maybe a single battery, and let's say one robot saw the battery first and took it and wants to use the battery, and then all of a sudden another robot saw the same battery. So now they have to somehow decide what to do about it. Both want that resource. Should they fight? Should they share it? Maybe they will fight and one of them will be destroyed and the other one will get the battery, but that other one will also have missing arm or missing parts. Or maybe they will decide to not fight and share it, and maybe one day this one guy has the use of battery, and then next day another robot has the battery until the battery runs out. Or maybe they will come up with some other arrangement. What will this depend on? The kind of arrangement that they would want to come up with. Will this depend on who saw the battery first? Who is bigger, who is faster. And these are all the decisions that you have to make and encode in the software that you're writing. So you will have about a year to write this piece of software, and you will think about all of these variables that could go into deciding how to share resources and how to interact and when to engage in conflict and when to not engage in conflict. Another person will write his own solution, maybe a different algorithm. And that person, she will put that code into another set of 100 robots, and then basically all 10 of you will put your code into exactly 100 robots, right? So when the robots are turned on, all of these robots wake up, and your code will start kind of waking up at the same time, and then the robots will start mimicking the process of life. So that's the setup. The important additional information is that you don't have to write the entire software for the robot. You just have to write this little plugin, gene for morality. Yeah, that's it. So for example, when this gene for morality decides that the robot should fight or should flee, should run or something, you don't have to actually write the code that manages the fight or manages the fleeing. That is already done. So the robots know how to fight, the robots know how to flee. That's done by other genes, let's say. Other pieces of software that are also called gene for fight or gene for running or whatever. Very crude and simplified analogy, obviously. So you have to just write one plugin, one piece of software that just makes these decisions. Whether should we get engaged in a conflict or should we do some sort of sharing. But how do you communicate with the rest of the software? And the company has come up with some sort of interface so that your software can communicate with other pieces of software. So what you do is the robot has internally some sort of, let's say, some sort of little representation where you can, there is a scale which you can set from minus 100 to plus 100, let's say. And we call this scale fairness. So if you set the scale to minus 100, then the robot will definitely get engaged in the fight and will defend the resource. If you set it to plus 100, then the robot will offer the resource to another robot. It will not engage in a fight, it will just offer the resource even proactively. And anywhere in between it will do something different. So for example, if you set it to plus 20, then your robot will only offer it to another robot if the other robot is running out of power. If another robot seems to be in some sort of trouble. So you kind of see what it is. And so that scale, the company calls it fairness scale. So you just set a variable. That's what your plugin that's what your plugin does. Yeah, Gene for morality. That's what it does. It just examines the situation. It examines certain variables. It looks at another robot. It looks into itself. Am I stronger? Am I weaker? Am I faster? How much do I need this resource, etc. And after that, just sets a single variable, which the company for some reason calls fairness. And it sets that variable from minus 100 to plus 100. And the rest of the software that is already written and put into the robot that will read this single value from you, and then the robot will either try to defend the resource or not, or maybe proactively offer it. And I think you understand what sort of analogy I'm striving for here. So this will feel, it will, so for the robot, this is the same as for me, say something will feel moral or fair or immoral and unfair. Yeah. So for example, if I found the battery and then another robot also wants that battery, if my morality says let's put it to minus 57, then what I will do is I will most definitely defend this resource unless, say, unless the other robot is really, really in need of this resource, maybe, or something like that. So that's it. Now, and I think so this is not an artificial setup. I mean, I think you can see that this kind of setup has value. This kind of setup not only has value, but it could be a very kind of good representation, maybe very crude, but also very accurate representation of how living organisms actually operate. Now, what will happen? So 10 of you, 10 developers, will all write different kind of code. And in 1 year, all of you have written your code, and it's put into 100 robots, and another 100, and another 100, and so all 1,000 robots will come to life after 1 year. What you will see happening is that some of you have done a good job, better job than others, and basically some robots will be more successful than others in interacting with each other and also in interacting with others. And you will see that one group and their offspring will start taking over. Yeah. So for example, I mean, if we can probably examine that. So if somebody wrote a very simplistic algorithm where regardless of the situation, you always set the scale to minus 100, so that if the robot finds a battery, it will always defend it until the robot is completely destroyed. It will always defend this resource with all of its might. So that will be very bad, because as you know, that resource will, this piece of software will wake up in 100 robots, and they will sometimes find the same battery at the same time. or maybe not at the same time. So both of them will always fight each other, and the big ones or strong ones will win and destroy the weak ones, but the big ones will also be damaged. I mean, they will lose limbs and they will lose parts, etc. So, and even when this bunch of this team of 100 encounters somebody from another group, still it will be not very. The outcome will always be problematic. Yeah. So maybe another guy comes up with an algorithm where this robot always gives up, always just says, oh, okay, I will take this battery, but if I see another one looking at my battery, then I'll always give up my battery. Then this is also not a great algorithm. So, I mean, this is actually even worse, probably. What you will find is that one of you out of 10 will have done a better job than everybody else. So your 100 robot and their descendants will be taking over the population. So they will have a higher overall average rate of reproduction. They will most often share the resources in a way that is more efficient than how the other ones will share the resources. And this will be true when two of your robots have an interaction between themselves, or whether they have to interact with somebody from outside the group. They will always come up with some sort of solution, whether they should fight or they should not fight. And this will be the kind of thing that whatever the other guys are doing, your team will still be progressing and prospering. Losing limbs less frequently, losing resources less frequently, but also not fighting for things when they should not fight, etc., etc. Now, here's the important bit. I think what you will find is that this algorithm that you came up with, say you are the winner, your team, your 100 robots is the winning team. What you will realize is you have discovered an algorithm that is very, very efficient, not by a chance. This algorithm will be you can say almost like a universal property of the universe. Like a mathematical, you've discovered some sort of mathematical truth, some sort of mathematical idea, an algorithm that is almost the best way of solving this problem. In computer science, these sort of things, such algorithms, I mean, not necessarily for this problem, but for other problems, say for example, you can say, how do you sort numbers into an ascending order? Let's say you have 1 million numbers all mixed up and you want to sort them into an ascending order. And what mathematicians and computer scientists will tell you that some algorithms are great, others are not, but they will also tell you that, for example, there is no way of sorting these numbers by using less than certain number of comparisons, million times log million with the base of 2. I mean, there will be some sort of things, some sort of universal truths about these algorithms that they will proclaim, that mathematicians have found. So you will find an algorithm that will be a universal truth in some sense. This will be, you can call it a property of the universe. In this universe, whatever that means, this algorithm will defeat any other algorithm in the setting that we just presented. This algorithm, this winning algorithm, will be the morality, will be is morality. That's what morality is. It's a mathematical principle. It's a mathematical set of rules. It's a mathematical algorithm which basically governs the interaction between these robots or these animals. And that's what is more or less discovered by evolution. That algorithm, instead of having these 10 guys in our example, evolution just kind of discovered this algorithm. And of course, I mean, evolution doesn't always discover the perfect one. It just discovers certain, the valleys and peaks. So it discovers certain local peaks, etc., etc. But this is not important. I mean, at least it has discovered some algorithm that is extremely efficient. It's discovered an algorithm for interacting and governing interaction between living organisms of your species, or between these set of robots, that is very good, very efficient. So that's pretty much it. That's my definition for, that's not a definition. That's an explanation or an analogy for the secular morality. That's the foundation for secular morality.